Hello legacy mathematicians, Marsh here. So today we're going to look at logarithms and natural logs, which is basically going to be a new type of notation that's going to help us solve for x. So guys, you're going to definitely want a scientific calculator. Your phone calculator is not going to cut it today. Then you're going to want your notes as well, okay? So, first things first, logarithms. All a logarithm is a special way to ask the question, what exponent is required to go from a base of b to a value of a? Logs are going to look something like that. It's going to say log b a equals x. And you're going to be like, well, how are we going to read that? So basically, to read that, you're going to say log base b of a is x. That's how you would read that. So you could actually speak the words. So log base b of a is x. That's ultimately what you're asking. Now, what a logarithm does, guys, is allows us to solve for an exponent. Ultimately, that's what it's doing. And ultimately, guys, logarithms and what's known as an exponential form kind of have this flip-flop nature that they can do. Exponential form you guys have seen before. That's like base to the exponent equals some value. So that would be like 2 to the third equals 8. So base, exponent, value. Logarithmic form, guys, is another way basically to get the exponent so I can have it equal to it. So log base of value equals my exponent. So ultimately, guys, what this would read out as is log base of my base, which would be 2, to my value, which would be 8, equals my exponent. Because logarithms are the only, what it's asking is what exponent is required to go from a base of b to a value of a. So base value equals my exponent. Hold with me. We'll try some conversion. So, I'm going to convert between exponential and logarithmic form. This right now is in exponential form. It doesn't have a log in it. That's how I know. So, I'm going to convert this to logarithmic form. So, that's going to have a log in it. Now remember, logarithms are just a special way to say what exponent is required to go from base of b to a value of a. So the base of my log is the base of my exponent. So that would be 1/5. And logs are the answer is your exponent. So my exponent is going to be the value or the equals x part, and the value here is y. Because what base of 1/5, what exponent is required to go from my base of 1/5 to get me my value of y? Ultimately, that's what it's asking. So let's try another to convert to log. So it's going to be log of my base 9 of x has to equal y, because your exponent is always your answer, okay, for a log form, log equation, or the logarithmic form. Let's now try to go backwards. Let's try to go to exponential form. So the base of my log is going to be the base of my exponent. So the base is going to be u. This, remember guys, my exponent was always the answer in logarithmic form. So my exponent is going to be v, and this is going to be my value. So u to the v power equals 15 over 16. Okay? Let's keep trying here. So 2 to the u power equals v. Okay? Now let's try some actually calculating the logs. That might help you guys see a little bit more of the pattern here. Alright, so ultimately, guys, what we're going to be doing is calculating the logs. We're ultimately going to be figuring out values for them. So I have log base 4 of 64 equals something, right? Let's call that something x. Now, off the top of our head, that is a really hard value to think about, right? We don't know what that is. So let's jump to exponential form and see what it's actually asking us. So what that is the base of 4 to some power has to give me 64. So 4 to what power will give me 64? So this is where you're going to want to borrow your calculator quick and just kind of do some guess and check. So 4 to the second, 4 to the fourth, and you will probably find that 4 to the third is 64, right? 4 to the third. So ultimately, guys, my answer for log base 4 of 64 is 3. Because remember, exponents, all they're asking, or the log form, is what exponent is required to go from a base of 4 to get to 64. That's ultimately what you're asking. So they are asking for this one, log base 6 of 216, they're asking 6 to what power equals 216. So we're going to do that on a calculator quick. 6 to 2, 6 to 4, 6 to 3, right? 6 to 3 is 216. So I know log base 6 of 216 equals 3. Let's try the same thing with log base 4 of 16. So I know 4 to some power has to give us 16, which is 4 to the second, right? 4 to the second equals 16. So log base 4 of 16 equals 2. Because 4 to some power equals 16, that some power is 2. What about something that looks kind of funky? Log base 3 of 1 over 243. So that would be 3 to some power has to give me 243. Whoa, 1 over 243. Hold on. I have no idea. Can't think that off the top of my head. So guys, there's actually a way to find out logs when you don't know the answer, or there is not a perfect exponent, if you want to consider that. It's what's known as the change of base formula. And it's going to be like log base b of a. And what you're going to do, guys, is you're going to use the log key on your calculator. You might want to find it quick. It's usually by what's like an ln button. Usually you'll find it near something called ln. It's going to say log. And you're going to divide log of the bigger size number divided by log of the base. So log of the value divided by log of the base. So ultimately, guys, what I'm going to do to find my value is I'm going to set it up as log of 1 divided by 243 divided by log of 3. So log of 1 divided by 243 divided by log of 3. And you should get -5, right? Now, guys, think through it. 3 to the -5. Remember, exponents. Drop down to the bottom, right? Negative ones, so it would be 3 to the 5th. And 3 to the 5th is 243. So ultimately, guys, if you are equal to a fraction, ultimately you're going to have a negative exponent somewhere in there. But don't be ashamed to use the change of base formula to make sure you're correct. But don't try to use it on every single one, because that's going to take you a little longer on, let's say, a test or when you're starting to solve these things. So then I got log base 64 of 4. So I know 64 to some power has to give me 4. I don't know that one either. Can't think that off the top of my head. So I'm going to get log base, or log of 4 divided by log of 64. And what are we going to get? It's going to be like 0.333, aka 1/3, right? So 64 to the 1/3 power equals 4, which remember, 1/3 powers was the cube root. And the cube root of 64 is in fact 4. So keep that in mind to convert logs. Now, let's evaluate log of 100. You're probably saying, Marsh, we don't have a base. Where's the base? Where is it? What do you do? What's your base? Guys, there is a thing called a common log. If there's no base present in your log expression, we assume the base is 10. So ultimately, there's a tiny little 10 right there. You just weren't able to see it. Now, since you now know that knowledge, you'll see that little base 10 when there's not something there. Okay? So ultimately, guys, they're asking 10 to some power has to give me 100. So I know my exponent has to be 2. So be aware, if there's no base on the log, technically there's a base of 10. Okay? Now, let's talk about a little bit of a special kind of log. And that is known as a natural log. And no, guys, natural logs are not logs that happen naturally in nature. But ultimately they do. That's where they found natural logs. They happen in nature. They occur more in nature than the regular log. And now, a natural log, all it is a base of e. So, log base e is technically just ln. So, they noticed it happens so often in nature that they made the base of a log, when it's e, they made a special form for it. So, that's ln. So, ultimately, guys, it is a logarithm with a base of e. Basically, it's the inverse of y equals e to the x, because we need to know how to convert that, right? Your abbreviation, ln, but it's not a base, but you should know it should be e. Guys, usually the ln button is located very close to the log button, the log button. So be able to find that on your calculator because you're going to want to use it in a little bit. Now, let's try converting between the two forms. So I got ln a smiley face equals $sign. So now, guys, this ln, it's kind of hard to see the base. So what I like to do is I like to rewrite and make that log base e. Because ln and log base e are exactly the same thing. It's just one looks fancier than the other, if you want to consider it that. Now, I can convert to exponential form. So then it would be e to the $sign equals smiley face. That's exponential form. Let's try ln of 1 equals 0. Well, that's still log base e of 1 equals 0. So I know that is e to the 0 equals 1. Okay, so doing that simple conversion first is going to be a lot easier for us to do it. What about e to the 4th equals 54.6? Well, guys, let's convert to log form first. So that would be log base e of 54.6 equals 4. And we know log base e is the same as ln. So ultimately, guys, I'm going to write this as ln of 54.6 equals 4. And that would be the correct and final answer. So guys, start associating in your mind. Log base e is ln. Okay? They liked it so much that they gave him his own function. Ultimately, guys, ln is something we're going to also want to be able to type in our calculator because you're going to have to use the change of base formula and that would take forever. So that's why the calculator people made an ln button. So guys, all you're going to be doing is plugging these into your calculator. So 1 plus 4 ln of 6. Now 6 is in the ln, the natural log. So you're going to want to make sure 6 is the only thing in parentheses. You should get something like 8.17. Check it on your calculator now. Make sure you get the same answer as I do. Because if you don't, you need to talk to me tomorrow so we can figure out what your issue is. Negative 3 times ln of 10 plus 1. Notice, guys, this plus 1 is not inside the ln. It's outside. So be very careful when you plug that in. Make sure you put parentheses around the 10. So it should be negative 5.907 approximately you should get. Same for this one. 2 times ln of 4 plus 3 ln of 5. Notice I'm putting kind of parentheses around the 5 and the 4. So that way I know what is inside the ln's. So you should get approximately 7.6 for that one. And then I got negative ln of 4 plus 5 times ln of 5. And you get approximately 6.66. So be aware of these, guys. Be careful. Please make sure you plug in the correct values and plug them in correctly. And that's the end of this video. See you later, Sabers.